Hello, my name is Michael Schultz. I'm here with the University of Florida in Jacksonville, Florida. Today we're going to be talking about tsunamis and nuclear power. My goal today is for you to understand the concept of both of them, how they work, and what happens with it in ASL. Today is April 10th, 2012. So I'll start talking about tsunamis. How is it that tsunamis happen? We'll talk about that first. There are quite a few different ways that it can happen. So basically it's water. It can be water from the lake, from the ocean, doesn't really matter, from an earthquake, from landslides. So if maybe a meteorite hits the water, or the earth shakes, or a landslide, you know how like water happens, like the continental drift that happened too, that kind of big barrier, or the drop off really, it can happen with that as well. So tsunami, the waves, they don't come for like a really like, oh, here we are, we're all coming out the waves, blah, blah, blah. No, that's not really how it happens. We'll talk about three major times. A meteorite could happen into the water, causing the water to go down and a ripple effect, and there's a pull. The land, the coast is kind of pulled in, and that's typically how it happens. You've seen it maybe in movies before, where the water is really far out and then you can't really see anything. That's exactly what we're talking about. The water kind of drops down and then it's pulling the land out. The landslide, it has to be really big. It can't just be a little drop off. And then sometimes the land will go down and then up and then pull that coastline out as well. An earthquake, same exact thing. There's the shake in the earth that happens and it pulls all of them. Same principles for all three. So how does the water get up? When the land is pulled, the water goes back too, and the water, from all this water that went so high up, it's coming out as well in some sort of ripple effect. It's kind of going up and down and not really a smooth process. In the center of it, in the center of the earthquake, the eye of the earthquake, for an example, Hawaii, it'll expand and go out. It won't go one specific direction. It goes out in a circle. So it could hit California, it could hit Japan. It goes out in a circular effect and then comes back into the middle, kind of pushes out. The water could go out pretty far because of the way, like a blanket kind of has that ripple effect. It's the same idea. The water comes back and is pushed out. No matter how high the water is, it's pushed out really far. Maybe 50, 20, 30, 40, I don't know. A lot of feet or miles. It'll go out there and out, out, out. Maybe 10 different like ripples. Maybe there may be nothing for a little while and then a lot of action. So those are really intense things. Remember a few years ago in Japan there was an earthquake not far off the shore. There's an earthquake that happened, and there was a horrible, tragic thing that happened, the tsunami that happened. It continued on, the impact, all the way to California. And remember, the earthquake in Japan happened like 2 years ago. Well, this continued on, and it was still going on in Japan. The shoes, they would find things in California that had been carried over all the way from Japan as a result of the earthquake and the tsunami that caught it. It could happen anything. It's really fast, or it could happen pretty slow. Okay, so that is about tsunamis. So we're going to go back to nuclear, like a nuclear site in Japan. There's like a base of it. They have, and it's active. They have a lot of impact on there, and I want to explain kind of how nuclear power works and the reasoning for it. So back to the destruction that happened, and then we'll go back to that. So nuclear power, what does it do? How does it work? Typically, there's 1 to 3-ish really cooling towers. Is what they call them. And typically people use 2 different like atoms. You have the lithium, and you put those in there, and the process works. The ammonium and then the neutrite hits it, and that breaks, 1 little drop of it. And that's called a nuclear fusion. And it hits and then divides, and when it divides, it's hot. It gives off heat. So understand that this one has the same nuclear power and does the same exact thing, and they divide as well. And so it continues on, a nuclear chain reaction, really. It continues on. And the heat intensity increases. The nuclear reaction, the heat also continues on as well. It deals with a lot of hot water as well, from the river, from the lakes. So they take water and they heat it up. And to change it, they change it to steam, and the steam comes in and out, and the pressure is really high, and it goes through this tube, like a generator type of thing, and it churns really fast, and then the electricity flips it and goes on out through there. That's kind of how it works. The earthquakes, however, well, let me back up. The cooling towers, okay, there's the water inside of it. Now, what happens with that water? It goes up to the towers, up into the cooling towers. It's pretty tall, and it's not full of steam. It's full of water, not all the way, but so anyway, you'll see the cooling towers. It's kind of like a kind of a square shape. It's not huge, but it is pretty big. So there's that. So in Japan, when there is an earthquake, they have 3 backup systems. If the earthquake happens, and then they have another backup, another backup to protect the nuclear power site. They have a couple different barriers to help that. And so nothing will be destroyed. So if if all 3 are destroyed, then that would really impact the area, the surrounding